Let's go back to that. All right.
Okay. Wow, I'm impressed.
So maybe should we start with a code sample that help like kind of everyone grok the thing. So maybe pull up CoreFX Lab and pull up like a unit test. Would be the easiest way to look at this thing.
Ping pong thing.
Which thing? Oh, the ping pong thing?
Oh,
Okay.
it is the beauty.
Yeah. Yeah, pull up a
Go to HP parse and just look at like take start line.
the samples. No, I mean like the factory creating the pipe.
Okay, my bad.
With both sides. Look at system. Yeah, that one. For example, this thing got super factored. Framing. Codec.
Really? Are you sure?
No. That shows some consumption. Okay, so maybe put the API side by side with the sample so we can look at the types and the sample in real time. Damn, good pin thing. So the first thing you start with is the iPipe factory, or I guess the pipe factory. That thing lets you create a pipe. The names are kind of bad because pipe is not like a name pipe, right? It's just
should we give a super high level overview?
Yeah, I guess we should. So a pipe is basically, think of it like a channel, right? So there's two ends to a pipe. This is a pipe, and there's someone that writes, and there's someone that reads, right? So today, if you look at, I think like a stream is kind of an abstraction that you kind of implement, read and write. In this pipe model, you create a pipe, someone writes from one side and someone consumes from the other side. It's kind of the basic primitive, right? The pipe itself manages all the memory. So when you call read, you actually get back a buffer. You don't pass anyone. When you want to write a buffer, it's the same thing applies. You actually allocate data from the pipe itself. So you say, create me a pipe, allocate things from the pipe, and then you call write, and then the reader gets data whenever the reader writes it to the actual pipe. That's kind of the basic primitive. So in types, to get a pipe, you use a pipe factory. So you create one of these guys with the buffer pool, and you say create pipe.
So the reason for having this rather than just new it up is for the pool?
The pool, yeah. So the pipe factory is kind of the root of the universe. So this guy has like the pool or whatever it has. You call create pipe. This guy gives you an iPipe back, which has a reader and a writer, and those guys kind of married to the same like inner structure. So when you call write on the right side, the reader can consume that data.
So you said that the reason for the factory is the pool, but you could just pass a pool to pipe constructor.
You could, yeah, you could.
So why would we not do it?
Because you get an iPipe back today. It's an abstraction. It's not the concrete implementation. And that pipe could be implemented with any kind of thing. We could expose pipe and have you pass in the pool directly, but it takes a bunch of parameters.
So you don't.
We haven't tried.
Yeah. So in the beginning, we had pipe via thing you could new up, but we kind of ended with a factory because it kind of mirrored to the whole. Well, originally it was like task factory, create task. This is like factory create pipe, but there's nothing that makes it like required to be a.
Yeah, we can easily move to the pipe options.
Yeah.
So why is pipe an interface?
Why do you hate interfaces, Chris? It could be an abstract-based class. There's no reason it has to be an interface. One benefit is that you can actually implement it on existing type if you want to decorate a pipe. So if you had a type that was like, if you had a stream, for example, let's say I had foo stream. It was a stream already. It could also be an iPipe. And I can make it do the pipe things and stream things and have it be on the same type without having two bits. I mean, you can't do two businesses in done anyway.
That's an example of something we actually are thinking of doing.
Yeah.
So how does this relate to the Windows pipes?
Doesn't at all. No. This is a fun name.
Why isn't this called pipeline?
So the reason I changed the name was because it makes more sense. So the pipe is like one of the things. The pipeline is like a bunch of pipes chained together. So if you had like, one other guy here, you could do this right
read.
So you build up this pipeline, and this is the pipeline, but individual things you write into and read from are pipes. The first name is channels, but then there's a thing called channels that's kind of not shipped yet. We're worried that people get confused with Go channels.
There's a thing called pipes that has shipped too.
I know, but the thing hasn't shipped anywhere else. So
no, the other
it's
one
currently called pipes. We had flumes, we had weird rivers, streams.
But conceptually, it's the same as a Windows pipe, right? Just I want to understand how you explain this, because that's going to be one of the very first questions you get. Is that we have pipes?
Yeah.
This is in process for one.
All right, so it's in process.
Think of it as a very low level abstraction that is a producer-consumer byte pump. So all it is you can write bytes and read bytes through a in-memory channel.
I would consider it a better stream, for performance.
It's more extreme than it is like a pipe.
Yeah.
It's a stream that manages its own memory.
Yeah.
Yes. Yes.
So it's like a data flow then.
It's like a data flow. It actually marries well with data flow and buffer blocking those kind of things. If you guys are familiar with Stephen Toe's channels, the prototype, it has similar concepts. You create a channel that is either buffered or non-buffered or bounded or non-bounded, and it has an in and an output. So in channels, I think writes are out and reads are in, and you write to one side and the consumer consumes from a different side, and you can pass any object back and forth. So that's kind of the main idea of how the whole thing is put together. You get a factory, you get a pipe back, and you read and write. So if you look at this sample, the sample is interesting. So this entire API was made for a couple of reasons. It tries to simplify common things you do when you read bytes from a stream. And it also tried to minimize allocations per read and per write. So the whole goal is you allocate the pipe once, and you can reuse the pipe. But every call to read and write does minimal allocations. So for example, in this basic example, you wait for data by calling read async on the input pipe. You get a result, you get the data from the result. The check is kind of wonky, so you have to check to see. So the reason you have to check for if the buffer is empty and the result is completed is because the writer can write a bunch of data and then close the write side, and then the reader can still be consuming, and you don't want to finish just because the writer said I'm done. So to drain the buffer completely, you kind of want to check for if the writer is done and if the buffer is empty by the reader.
So why don't you provide a helper called is data available or something like this?
Where?
On the reading side. So instead of calling, empty and not empty and not completed, you say, do I have more data to consume?
On the reader itself, or on the result that you get from there?
Yeah, think about, in this example, it would be input no more data. So you would say if input no more data, then break.
Input is the buffer itself, though. The buffer itself is a thing that is made when you get the result back. It's like a result from a read.
Mm-hmm.
Yeah, we could have
it can be done. It can be
it'd be on result, not on buffer, but it could be done. Yeah, if result is the entire thing completed, yeah, instead of having you check both things.
Arguably, that's more useful than is completed.
Yeah, the funny yes, that's true.
So what type is input there? Like this input property here?
Bar. I'm kidding. You can't tell. Hover over the result. It's a read result.
So this is not an actual pipe then.
Oh, it's pipe reader. The one you selected
like
is
the
pipe
highlighted
reader.
thing.
Yeah. So the input is a pipe reader, and the output is a pipe writer from the connection.
Where's the pipe?
In this scenario, the pipe is pretty much the connection. You can ignore that for now. Pretend that thing is an iPipe. The connection is
very close.
Yeah. The reason this thing isn't okay. So you can tell me if it's stupid.
It's stupid.
Hold on.
It's the full duplex pipe.
So in this model, right, this is a single side of a pipe, right? So you can imagine for a connection, a duplex connection, you have two pipes, one for input and one for output, right? So this is the input pipe, and this is the output pipe. And depending on who you are, you consume one half of each side. right? Does that make sense?
Sure.
So if you're like, so imagine this was an application, right? So there was an app, and there was like a transport, like sockets or whatever. The sockets is producing data to the application. So whenever it reads data from the underlying socket, it writes to the application's input pipe, right? So the transport is running it to the application input pipe. When the application wants to write data to the socket, it writes to the application's output pipe. So kind of the socket owns one half the input pipe and one half the output pipe. So we added a thing called iPipe connection to represent full duplex, like a half duplex pipe. We could have made it be iPipe, but it's the same interface, but it's kind of to indicate that it's not kind of one pipe. But we could have made it the same.
It
same
just
pipe.
to say that it's two ends.
Two
of
ends of the
different
same,
pipes.
yeah, different pipes.
So I forgot. It's iPipe connection. Is that what it is?
Yeah,
Is that duplex?
yeah. And to be fair, we don't need different type. It's just that it made it more obvious that this is two ends of different pipes versus it being two ends of the same pipe.
So should it be called pipe duplex pipe?
Could be.
Yeah.
Yeah, high duplex pipe.
But it shouldn't be the same interface because then, if you take iPipe,
Yeah.
you expect it. If you write to one side, you expect it to be readable from the other side. And if you make
could
it
be.
the same, you would get strange.
I'm not understanding. How could
No.
it be at the same time? Same than what?
Same interface. Like interface looks
It's
exactly
the same signature
Same
as
signature.
the both sides of a non-duplex pipe. Because they both have input and output.
Yeah.
It's kind of attractive just because you reduce the number of concepts. You have one iPipe. The only thing is you conflate a single pipe versus two ends of a different.
Yeah.
But you can admit iPipe being two different ends of the same, like.
I think they need to be different types.
Yeah.
I agree.
Prevents,
They're semantically
prevents-
way different.
How do you describe two types that have the same signature but are different semantics? Exact same signature. Like iPipe and iPipe connection look the same way, but they're just
Giving different interfaces.
you can The interface name is the only thing we have to do to make it look different, but it pretty much is the same thing.
Mhm.
Move on. All good so far? All crazy? All right.
I try to keep the concepts in my head, which is actually not that easy.
So I think if you take away anything, take away the fact that it's a
You can write out that interface really
Yeah.
quickly. Right?
push. Which one?
Or you can just look at it.
Yeah. Look at
iPipe
iPipe.
connection or iPipe.
look at iPipe first.
Oh, see, now they're different.
Yeah, they actually have different names now.
For now.
So if you were to look at the right side, you see that.
That's another.
Okay, so iPipe has reader and writer, kind of both sides to the same pipe, and iPipe connection has input and output, and they're both the same types on the properties, but they're different concepts. So
That makes no sense to me.
no,
No. Like, to me, that seems like exactly the same thing. And iPipe
It is.
and iPipe.
So the iPipe, if I write to the writer, I can read it from the reader.
No. This is iPipe.
Yeah, there's the graph
Um,
illustration.
This is iPipe connection. Actually, is this
yeah,
Yeah,
that's
or
right.
it's exactly right.
this and this?
No.
No, that's right. That's right.
Oh, yeah.
Or is it this like
It's diagonal.
diagonal?
Yeah. So this is connection. Jeez.
This diagram.
Sorry, I messed it up.
It's fine. Does that make
So
sense?
there are basically four sockets. iPipe has two sockets at the end. iPipe connection has two sockets diagonal from two different pipes.
So you want to think about it as data flowing from the reader from the writer to the reader. So you're
If I call writer.write on an iPipe, and later on I can retrieve that data
from reader.read. Yes.
It'll be buffered.
versus an iPipe connection is literally I'm talking to opposite ends.
Yeah.
Yes. Yep. One is like socket versus one. Yeah, I guess socket versus stream. Well,
No.
no. It's more like socket versus.
So
like
iPipe
one
connection is
socket.
more like a stream. It's more like a duplex stream.
Yeah.
Is iPipe connection.
Yeah.
There's really no analog in the stream for iPipe.
Okay, now it suddenly makes sense. Okay.
Nice.
I cannot reset my pipe connection.
Huh?
I cannot reset my pipe connection.
Reset shouldn't be on the iPipe, to be honest. It should be on the implementation. It shouldn't be on the abstraction. Reset is there because of reuse. So in Castro, we want to reuse the same pipe for multiple requests for perf. So we add this reset thing. It really should be on the pipe implementation, not on the interface, because the actual consumer doesn't care that it's like resettable.
But the factory gives you an interface, and that's what
Say,
they get.
Unfortunately, it does. I found a bug to make it not give you an
So
interface.
can somebody collect those decisions? I think this one is a good one.
Who's taking notes? Who's taking notes?
I'm trying to take notes.
So I like the high duplex pipe name.
Yeah. Connection
Like,
is
connection
it's a bit networky.
All these should be networky though.
Uh,
I don't know.
You'd use it for
It's a
audio.
process, man.
The duplex makes a lot of sense.
then let's call it wire. iWire.
That sounds perfect.
Actually,
Wire pipe.
is anything else using wire? I do struggle coming up
Yes,
with names.
wire is the name of the product actually.
Damn.
Okay. Serializer.
I meant our product.
No. Okay, so let's get through all the big concepts in this meeting. So factory creates a pipe. Pipe has two ends. You write to it. You read from it. The connection is different. Is a duplex pipe.
You have to go through reader and writer.
That makes sense. So let's go through the reader and writer, I guess, and on the interfaces.
I was about to say that's the next logical step.
Yeah, iPipe reader. Writer reader first.
Writer.
Right. Yeah, writer first.
Yeah, probably.
So, like I was saying before, one of the main goals was to push memory management to the actual pipe itself, because it manages all the memory of the pipeline. So you allocate from the actual pipe itself. So you allocate, you pass in an int, that thing that's not really work very well, but you pass in an int, asking for some kind of size. You get a thing back you can write into, and then you call flush. Cancel pending flush, we can discuss.
You want to flush on what, the writable buffer?
Yes. Yeah. So think of it as like you get a memory representation of a thing that fills up a. You can. It's kind of like a stream in that sense, I guess. You get a thing back, you write to it, and then you call flush to make it go. The actual.
And then is it dead?
It's
You
dead.
return it back to the pipe?
Right. It's dead. No, it's dead. And that's an interesting design question because you can't really kill it, but it's dead.
How many concurrent allocations do you support? Only one, right?
Only one.
Yeah.
It's single producer, single
So why
consumer.
do you return a value at all? Why is it not a state on that thing itself?
On the writer itself.
That's basically what it is.
Yeah.
Seems like more what you want is like start with the size and then write, finish.
It's the same thing. I mean, it
No,
could
but
be.
I agree. It seems like there are too many types. There's like a chain of types.
Yeah.
But because iPipe writer could just, you basically alloc,
Mm-hmm.
then you can keep asking for span, and then basically you can flash. Like output is like
Pretty much
this.
what the buffer is itself today.
I think we wanted
You're
smaller
saying-
surface to pass it down
to pass to other things. So like
to other things.
in theory, this thing would implement an interface like I can write to this thing, right? And you call out, you get a thing back, you pass it to a bunch of methods that format into it, like format int, format string, format blah. You get it back and then you just call flush, right?
But what I'm saying is, and what I thought Imo was asking is, basically all the APIs that are on the writable buffer
Can be on thing
could
itself.
be in here directly.
It could be.
And then we would have, first less types, and secondly less kind of like, how far do I have to chain till I actually can do some work?
I think we wanted like a primitive for buffer chains, kind of on top of that don't involve the entire writer that you said you could.
It
pass
could be
around.
implemented on the actual pipe itself. If we had one. We don't have one yet.
So the reason, one of them is fewer types, fewer concepts. Secondly, I think your API, you have to look very carefully, but otherwise it lies to you, right? Because you can say, hello, get a buffer, passes around, allocate again, get another buffer, passes around, but that's not what this API
You can't do it.
supports.
No, it's one at a time.
Right.
It
You
prevents.
only have one concurrent buffer.
Right, start, stop.
Also, we were fighting on this too. How many concurrent allocations do we want to support? That's why it's there.
Right.
Yeah. Because we were not sure.
Thinking of supporting it, but that went away.
Yeah.
Yeah, we could. What do you think it would look like?
Just like
Add-
current buffer advanced and
Yeah,
flash.
it'd be exposing the actual span, well, the memory on here
Memory,
itself.
yeah.
Basically, like I output, correct?
This is output.
Yeah.
Yeah, it's pretty much the output with a flush.
And by the way, we need to add flash to I output. I ran into so many cases. I output is like a type that we have in CoreFX Lab for very similar scenarios. We
It's
need
like
to
stream writer, but without chars.
Seems like we have way more content than what we used to, though.
Yeah. But don't worry, it's all good. Okay, so that's good feedback. So there would be a way to allocate a buffer. So you still need a way to allocate a buffer, though. Maybe we call alloc start, or we just call it alloc and it doesn't return its void.
Yeah.
And you write into the actual.
Initialize.
So I mean,
Why don't you do like on-demand allocation when you actually pull on the buffer?
on the span itself in the
On
property.
the memory.
FXCop says you shouldn't do its kind of things in the getter.
FXCop is such a
No, I mean, but
sophisticated
it's
analysis.
too implicit.
Okay.
Yeah. I think you kind of want to say like, give me memory.
If you promoted it, then when your flush kill the writer, the pipe writer, is it done when you flush? There's no more writing.
It's not done. Complete is that. So complete is like I'm done writing completely. Flush is like flush my current buffer data.
Yeah, there's a
Tell reader that I wrote a thing.
Yeah.
You can also make that allocate if you want it to be. That's not alloc.
Yeah, no. We had an argument. I should allocate too. But cancel pending. So when you call flush returns unawaitable.
What do you mean by calling flash? There's no flash.
It's on right.
On
Writable buffer.
Oh, we
Okay.
should look at the buffer.
Yeah.
Emo. Do some work, emo. Where's the buffer?
Where's the buffer? Writable
Oh, that thing.
at the end.
Writable buffer.
Alphabetically, W is at the end.
So this thing is kind of a disaster, but
It's all good, trust me.
let's explain this one a little bit.
If it implements I output.
Yeah, so you get a thing back, right? And you can get the buffer from it, so you can write to it. But it has a fixed size, and then when you want to grow it, you call it ensure, or is it called ensure?
No,
It's called ensure.
Oh, sure.
Yeah, so
How are you growing it? You already allocated a fixed size.
but it can grow forever. It's min size required. So you say like, give me 4K, and you write to it. You're like, oh crap, I'm on the data. Then you say like grow, and you keep writing to it over and over and over. So the idea is to have enough things on here so you can build higher level methods like write. I can do like.
So if
grow
you
and
promote
write.
this up, then it shouldn't be allocated. It should be ensure.
Should be something.
Because if you're going to change it, you just
Yeah.
call it
Yeah,
ensure
yeah.
again.
Allocate is pretty much ensure.
Yeah,
Pretty much
ensure.
So actually, yeah, so you know, like basically if you don't call ensure first, you would just return like an empty thing,
Yes.
which means you don't have to allocate this fast and FXCAP doesn't beat you up over that.
Yeah.
And then you have to call ensure.
As long as there's no like implicit grow when
Yeah.
you like
Yeah.
access them.
Yeah,
that's
yeah.
fine. That's fine.
I would better throw.
Yes, that's fine. Oh, you like throw up everything.
I like throw because it prevented so many bugs in our application. If nobody called ensure, then nobody writes nowhere.
One thing that
Right,
can happen,
but that's not what he's saying.
Infinite loop. If you're like trying to write and you don't call ensure because nothing grew. I guess ensure always has.
But that's true anyway.
Yeah, I mean,
I
come
know,
on.
but okay.
So then you see like all these APIs would move to iPipe reader,
yes,
and it would be so nice. I mean, like you just call ensure and then you get the buffer.
Yeah. We can merge them. There's other things like you can get the data that you wrote by calling as readable buffer.
Yeah, that's wrong.
In what scenarios do you really want that?
Oh,
Yeah, the other end of the pipe want it, but not you.
super useful.
You just
No,
wrote it. Why do you want to read it back again?
Let's
It's not,
go.
it's for reasons.
Give me one of those.
Trust me, there are
For
reasons.
good reasons. Add that. So I think people are beginning to use this thing as a scratch buffer, which may not be the intent. So like you allocate a buffer and you just like write to it and you're like, give me what I just wrote. But for that, it's kind of like using the buffer pool by itself.
Yeah.
I guess you don't really need it. I'd be okay with getting rid of
Make
it
it
for now.
actually a writer.
I'm looking to see. Well, there's nothing wrong with like looking at what you just wrote. There was actually a case for it recently that I've never seen, but I can't remember what the case was now. Like it was trying to get the length. That's what it was. So you write a bunch of data, and you want to get the length we just wrote.
The so-called bytes written.
And you want to get the content so you can log it. Boom. Yeah.
Let's clean it up.
You just want to
Remove it.
You just want to remove useful things.
You wrap your writer and you keep track of it yourself.
There's so many ways. You can't if you could decorate this thing properly and you could like pass through all the data, that'd be fine.
Yeah, it's now moving all up to iPipe writer. It's an interface. You can wrap it all
you can't decorate this thing because you expose a buffer and you can't you can't wrap the buffer that was returned to someone else that was written into. That's why it's so hard to look at the data. Like stream, you overwrite.
Doesn't buffer already have reading APIs as well?
Buffer is like a array.
Yeah, so you have a way of reading it.
You can't decorate that thing.
Well, but you have a way of reading it.
So imagine you wanted to create this thing, pass to a bunch of APIs that read a bunch of stuff, right? That you had no control over, right? And then you want to see what got written.
Yeah, you look at the buffer.
How do you do that?
On commit.
Look at the buffer.
Add the buffer when you overwrite commit, and then you look at the buffer.
It wrote 15 chains of buffers.
Yeah.
So the buffer you have there is the last one,
But
not the entire
each
chain.
time it wrote, it said advanced or ensure.
How do you look at the buffer?
Still.
There's no way to decorate.
You own
You
it.
cannot decorate this thing. Like in stream, you overwrite right. You think you handle all the right calls. You can look at the buffers as they pass through. They say you can't do it. Whenever someone calls commit or advance, like what do you do?
Okay, come up with a scenario why you need to read it first, and then we can talk about it more.
It's like saying why would anyone decorate stream ever? Wait, if you can find a reason for anyone to decorate stream write and read, you can find a reason to fill the buffers here. Same idea, right?
I feel like we're doubling the complexity. We're having a writer APIs that allow you to read, and then we're going to have a reader APIs that kind of allow you to write, aren't it?
And
We haven't looked at it yet.
All right, let's move.
let's move on.
I think it's a good feedback, and you can always add it later. But
Yeah.
like if you really think that it's
There are certainly workarounds to not having it.
There's no as writable buffer. Are you sure?
It doesn't have to because this thing you can write to it. You can write to it today.
yeah, unfortunately,
what?
readable buffer has buffer of byte on it instead of read-only buffer of byte.
Yes,
So it's
yeah. I understand.
For reasons.
There are good
reasons.
reasons.
For reasons. They're bad, but they're good.
So what are the reasons?
If you have this chain of data, this pipeline, imagine this is like, I don't know, compression. Or this is kind of like pipe 1, this is pipe 2. And this process in between doing this thing is compression or whatever. So you want to take the data from this pipe and like change it in place in this pipe. It's terrible, but like, oh my god, it's amazing.
With the code URLs without allocating.
You do it in place.
And for compression, it doesn't even work, right? Because it could always be bigger.
Decompression.
Wait,
That's
that makes less
Compression.
sense.
It's dirty reasons.
I don't think it's bad though.
So which API are we talking about that does that?
On the so when you consume data from a pipe
Yes.
today, if the change you guys want to propose is to make it read only. I'm saying there are cases where you want to turn that buffer into something that is input for a different pipe that you want to write into. So you may want to edit it in place to do a transmission without allocating, and then pass it along to different buffers.
Yeah.
And while it may be pure to have it be read only, it prevents that from working altogether because you can't ever cast to a.
So I almost think that I understand the reason, and I think imagine that the terminology was not writable buffer, readable buffer, reading, writing, but input and output. And everything is read-write, and they are just inputs and outputs. That's basically a better terminology given this model.
Do you think infinite output will be confusing?
Yeah, it is confusing because
depending
you
on
never
where you
know
were,
whether-
depending on what side you're on, you're like either input or
So
output.
that's why we use, reader and writer, but it has the negative that what you actually mean is pipes are just transports of
Yes.
read-write byte arrays.
Yes.
They're not for reading or writing. They are just transports of.
I want to rename this to byte buffer.
And the reader and the writer just correspond to the ends,
Yes.
not to what you're supposed to be doing with this data.
Is reader and writer really less ambiguous than input and output? Like reader and input seems
Maybe the same. Yeah, I don't know.
Thinking the same thing.
Well, it's
Don't
probably
seem
the
any
M plus, right?
more ambiguous.
But I do think the name Writable Buffer is wrong though. I mean, it should be byte buffer. Just byte buffer.
I don't know. We also allow returning the same. Like if you didn't consume entire data, we'll give you the same blocks again when you read next time. And if you modify them already, like this can cause all kinds
Bad
of
things.
bad things.
Possible.
Like you get it the first time, you think you have enough, you modified it, and then you don't have enough, so you say, okay, I didn't consume anything, and you get it next time, and it's mutated.
Yeah, the only problem is I don't feel comfortable removing it because we only have a single scenario that we use pipes for today, which is like catching the sockets. But if we ever do like anything where we want to modify the buffer in place, I mean,
if in an API review, I think the argument that we should have this API just in case because we only have one scenario is kind of a tough argument.
It's not that. It's that we actually know a scenario where we actually want to mutate run this callback in this location. This is like super low. This is like if you're going to implement a primitive for scheduling things, this is what it would look like. Like Java has this thing called Runnable. It's basically it's the same interface, right? And you can pass it to arbitrary things that can schedule callbacks anywhere.
But it takes action of what?
Object. All it is literally run this function, like do a thing with it.
So it's just a delegate.
If you want to take parameters or return, you have to put them
it's
on
the thing that
object.
accepts the delegate.
It's a closure. Wrap this closure, correct?
Wraps the delegate, which is exactly what a delegate does.
No, you have to pass it the stuff, right? It's the thing that.
Yeah, we should discuss it with Steve.
Yeah,
Because I do agree with
I took
you.
an action on Cortex for this.
If we need this type, then it probably should be in VCL,
Yep.
unless we already have a type that should work for you.
Yeah, totally agree. It doesn't work for me.
Basically, you use a work item as an abstraction, right?
Yes. Yeah, exactly.
That's what it is.
Actually, in Catch-All, we have a thing called iThreadful. That's basically the same thing, right? It's like, tell me where you want things to run. So, for example, for our perf text, we have thread scheduling mode dot run inline, which stays on the current transport thread, so you can run single threaded on the BV like in our pipeline. You can just do it with a single like scheduler. So you say when you are doing callbacks for reads, make sure it runs on the BV thread, and that's how it kind of works.
Have you checked? We surely do not have something in that thing.
You don't. You have nothing.
I don't see anything yet.
Nothing at all. Nothing good.
That may be jealous.
I'm kidding.
So even though, even if we, it's not VCL saying,
Yeah.
I would not put it in this namespace, and I
Agreed.
would not
System
call
threading,
inline scheduler.
Yeah.
Should it be an abstract class?
For you, Christoph?
Why would you make it an abstract class?
Because then we don't have to have a type called inline scheduler. We can have a type called scheduler that default or inline, and it solves many problems.
We can have default implementation.
There are
of
many benefits of
this interface.
we can always throw the inline scheduler in some static
if
type
we-
by scheduler.
If we discover that, for example, it's very costly to pass an int through an action of object, we can add an overload that it takes an object action and an int.
Add new interface. I schedule too. For that. No, I think we should agree on the low-level interface. And you'll agree it'll be so minimal that it won't require a laptop-based class. But if it did in the end, whatever.
If iService Provider was an abstract-based class. Yeah,
I don't feel that bad about that one. That one's fine.
And nobody will ever need more than 1 megabyte of disk space.
They never did. No.
Not even memory.
You just redefine the meaning of a megabyte.
Yeah.
All right.
Okay, so one more thing I want to bring that's pretty important before we go on iPipe Reader. There's a call to advance. This is kind of a fundamental thing that is a difference between this and stream. So when you call read async, you get a result back that has a buffer, and that buffer will not move until you call advance. So and it's super important. So let's say the writer wrote some data, right? That's how it looks in the queue. So the writer is here, and the reader is here. Think of it as a cursor, right? The reader has a cursor to the infinite chain of buffers that was written by the writer. As the writer continues to write data, the reader is consuming it, pulling the writer until it goes that way, right? When the reader gets a buffer back, let's say it called read, it got this data back, right? The reader has to call advance to move its cursor to whatever it consumed, right? If it doesn't, and you keep calling read, you get the same data over and over, which means there's this idiomatic loop that you have to do where you say read async, get some data, call advance, right? So that's kind of
Why doesn't it just advance as it reads?
So we thought about auto advancing. It was easier to have an explicit API because we want the opportunity not to advance. Say we hit some kind of separator when we're parsing. We want to be able to advance to that separator, not copy out the stuff we want to parse next, and basically restart the loop with just another call to read async.
So I think that I agree. I understand why the scenario exists. What I still don't feel super confident is that you have two cursors. One for seed and one for consume. I would just simplify it for just did I consume or not?
No, because you want to await. So you don't want to take up a thread if you have seen everything but haven't consumed everything, right? So that's the way to tell us that, hey, I saw all this data. It's only like half the data. I don't want to copy it because that's
Yeah.
all we're trying to
So-
avoid. And I don't want to be blocking a thread.
Yeah, but I would
until
say
it's not data.
if you call read, you've seen the data.
No.
Why not? When would you call read and not see the data?
Because you want to lead data to next component.
Right. Yeah, you have like multiple like methods, and they each call read async or whatever, and they parse different like sections.
So is that basically like peeking ahead? Is that
Yeah,
It's like peak, yeah. It's like peak.
Do you want to do like super close notes on back pressure? Like
Yeah. So one other thing that Advanced does is
2 minutes?
there's this chain between there's this pull between producer and consumer, right? I mean, the producer, when you want to be in a situation where you don't overload the consumer, you need a way to tell this guy to back off. So let's say you create the pipe with size like 10, right? And when you write 10 bytes have been consumed. So when you get past the threshold of this buffer, Advanced kind of relieves the back pressure from the actual producer. So when you set Advanced and you mark data as consumed, you're relieving this number to be like whatever data is.
So to be clear, until you hit that specified buffer size when you create the pipe, flush async always returns completed task. It's only once that buffer has been filled up that flush async returns an incomplete task, which completes once the reader has consumed enough of the buffer that there's basically room.
And that happens when you call Advanced. So when you call Advanced, that act will free up how many ever bytes you consume based on what you passed in as a cursor.
So another question idea. Could default be I've seen the data and you have a separate API that you can say like I unsee it because I want to.
We thought about that.
Because I think it's
Just
so
seemed gross.
confusing like for people to call read,
Advanced freeze memory.
get a buffer and
I don't. Yeah.
and
Can
Yeah.
this be considered not seen.
Can you have a separate read and peak?
I'd rather rename read to just be peak.
The thing
That made the default consume everything. Because consume everything means return to the buffer pool. Advanced is like is a step that says return to the pool and document the ref count for me. And that actually hides ref counting from like consumers. They don't see it all because
No. I have
read
no
advanced.
problem with like indicating when I consume data. What I have a problem with is two parameters. One is I consume the data, and the other one is I see which.
There's an
There's
extension
an
method,
one.
that just takes consume.
I know, but it's
But the
confusing
interface
because
has-
you look at the API and you cannot understand what the heck is this thing. Like, how can I not see data? I just read it.
But I don't want to remove from the interface when there's a way to just have an overload that does the default behavior for like the most obvious case.
This is kind of one of the benefits of abstract baseline.
Exactly.
I mean, is it really?
Yes, it is.
Extension methods are much better.
So for people who don't see, because we don't see the parameter names, advanced takes two cursors, and one is basically says how much data I've seen and how much data I've read. And I think that examined is so weird.
The name
I
is
would
weird.
not know what to pass there.
You do. The moment you have written code that like is parsing some protocol, like this all like just kind of gels. Right?
I think to use this API, you're going to want to see an example or a tutorial or a sample first.
Yeah.
Yeah.
Because it is
So
unique enough.
then what I'm saying, but it's such an advanced scenario to basically say I haven't seen it that what I would do is by default you just call advanced, and when you consume, it's assumed to be seen when you read, and you can basically call another API.
Yeah, that's
to
how it
say,
works.
Yeah.
You just call another overload.
Yeah, that works today.
You pass a single thing.
You just hit the interface is all. But like, there's a thing called like
Yeah, the
reader
extension method.
extension that literally takes one thing and it passes the same for consuming examined. But it has to be an interface because that's just the lowest level. Like,
If we take it from here, we won't have functionality.
yeah. But I agree. Like in the most common case, you call it advanced as one buffer.
I think what would help also is if they have samples that are actually minimalistic. I think your samples are all too complicated, as in
Yeah, they're bad.
too many concepts.
Yeah, I didn't come prepared with samples. I'll do that next time.
I think what would really help is like having a dedicated sample that literally
For
just
each scenario.
5 bytes puts in 10 bytes.
and doesn't use var.
Impossible. I'm sorry.
I don't care for var.
Refactoring, like you can right click on var and say like just or on the whole file
Unvar.
get rid of the unvar. Unvar.
That would be the worst thing you could ever do.
It's called nevvar in the IDE.
What is it?
It's a nevvar menu item.
Oh, really? Yeah.
I love you.
Actually, the problem you can do is that you can just do control.unvar and then say change in all files.
You can't actually know. And then all files. Really?
All projects, current
Who
files.
would ever use that though? That's a question.
I do the other way around. It's like, fuck this shit.
Yeah,
You only write because you never read it.
Dude, I mean, that is true. But I use IDEs that like show me the type.
I should review one.
Maybe read that.
I built something new. I should review one. I built something new. I should review one.
They review my.
Or feature request for GitHub. There should be like a HTML, what are they called?
Oh,
like
yeah.
tags.
Yeah.
Just so I can GitHub. Features in the website are not replacements for bad coding conventions.
Those are good coding conventions. What they add in the first place?
What about your API Studio email? Does it like use var ever?
No,
does it show?
because we don't see.
It's the local variables inside. You never see them.
So, but the samples will be helpful.
Yep.
And then like really streamlined samples that really show the mechanics.
But I think we got through like most of the core types. The only thing we didn't explain was
I don't think
that matters.
pressure was.
That matters.
explained.
It wasn't. That's too fast. But
Oh yeah, and also we didn't talk about the awaiters.
yeah.
Yeah.
All
There are
different ball of twine. Oh, this is
Oh,
so
everyone
bad.
agrees. The name changed like 4 times.
Like people, but not really.
Since we already have a.
Name pipes. Yep. Let's call it. Let's do this whole name again. No. No.
Come back with it.
Just so you want to review this faster rather than longer, right?
What is it?
You want to review this faster rather than
Yes.
right? So another 2-hour slot this week will probably be good.
2 hours would be good.
Preferences for a day. You were working from home on Thursdays, I believe.
Wednesday tomorrow.
Wednesday. Anybody else going on Thursdays? You know, we'll set it up for Thursday,
Yeah.
and then you can.
Love samples and just samples.
Perfect. Then I want to have lunch.
Some awaiters.